Hey everyone, and welcome to today's Explainer. We've got a genuine tech mystery on our hands today, and it is a wild one. We're going to unravel the story of a critical vulnerability that was literally hiding in plain sight, deep inside one of the most widely used pieces of software on the entire planet. And it sat there for 6 long years. It outsmarted incredibly brilliant humans, but well, it couldn't outsmart a totally new kind of AI architecture. Okay, let's dive into this.
Section 1. Ethan's Tuesday morning. An unexpected notification.
So, meet Ethan. He is an 11-year veteran on the Windows networking platform team, and he had some very strict morning rules. Rule number 1, absolutely no Slack before coffee. Rule number 2, never, ever open the security dashboard before the second cup. And you can't really blame him. He knew from painful experience that the panic-to-signal ratio in enterprise security hovered around 40-1. That's a whole lot of noise. Having survived the massive IPv4 to dual-stack transition, he was totally used to chasing ghosts in the machine. So when his laptop chimed at exactly 8:47 a.m. on a Tuesday in March, his immediate gut instinct was just, oh great, another false alarm.
But then, he actually saw the alert. MDASH, priority finding, tcp/ip.sys, authentication boundary. Yeah, he definitely poured that second cup of coffee before opening it. See, this wasn't just some vague warning or a weird code smell. What he was looking at was a fully realized complete exploit path, traced perfectly through 847 lines of complex networking code. It was already proven, literally, before the morning stand-up even finished.
Section 2. The hidden 6-year bug hiding in plain sight. Now, what's really interesting about this finding is
it had a 9.8 CVSS score. For anyone working in enterprise security, that number is a massive, flashing red light. I mean, it's absolutely the nightmare scenario for an operating system. A 9.8 means a remote, completely unauthenticated attacker can execute arbitrary code right at kernel privilege. It's basically handing over the keys to the kingdom. And just look at the timeline on this thing. The vulnerability was actually introduced way back in 2019. It sat there completely silent for 6 years. Think about that. It survived 4 major Windows releases. It bypassed intensive security audits, penetration tests, and brutal red team exercises. It even slipped right past 3 different security leads, and 2 of them had actually manually reviewed this exact section of code, just waiting there until March 2026 when MDASH finally caught it. So how exactly do brilliant, seasoned humans miss something so critical for so long? Well, Brooke, the team's security architect, hit the nail on the head. She called it a layered assumption failure. You see, the TCP state machine and the authentication validator were actually totally correct in isolation. The vulnerability lived in the invisible timing dependency gap right between those 2 subsystems. To actually spot it, a human reviewer would have to hold both incredibly complex subsystems in their head simultaneously, and then map out their timing dependencies across a 200,000-line code base. So actually, scratch that, it's not a failure of human intelligence at all. It's just a failure of human cognitive scale. We literally just can't hold that much in our brains at once.
Section 3. Inside the MDASH harness. Not just the model.
Okay, so let's talk about the detective of our story. Microsoft is extremely deliberate about one crucial distinction when it comes to MDASH. It is not just an AI model. It's an orchestration harness. We are talking about a highly structured pipeline of over 100 specialized agents running in sequence across a whole ensemble of different AI models. The models themselves, they're almost just interchangeable parts. It's the architecture itself that is the actual product, doing all the heavy lifting here. Section 4. The 6-stage pipeline, how MDASH processes code. Let's move on and see how this builds. Because here is exactly how MDASH finds the invisible. First, it prepares context maps to understand the actual behavior of the code, not just what the documentation claims it does. Then, it unleashes a whole fleet of parallel scanning agents. These guys have super narrow, highly specialized mandates just hunting for specific flaws. But it doesn't stop at just a theory. Step 3, it validates reachability, checking if the flaw can actually be exploited in the real world. Then it ruthlessly debates its own findings, dedupes everything down to a single root cause, and finally proves it by literally constructing a functioning exploit path. It hands the engineers a proven, closed case, not just a guess.
And honestly, this highlights where the real magic happens, that debate stage. On one side of the ring, you have the finding agents, scouring the code for vulnerabilities. But opposing them are adversarial agents. Their entire job? to actively argue that the finding is totally safe or that the right conditions can't possibly be assembled. The system literally fights with itself. It applies immense adversarial pressure. And this is exactly why MDASH keeps false positive rates so operationally low. It filters out all the noise before a human engineer is ever even alerted.
Section 5. The new security environment, a paradigm shift in infrastructure.
Because MDASH handed Ethan's team the definitive root cause and a proven exploit path right out of the gate, they were able to write a patch for this 6-year-old critical bug in just 2 days. 2 days! David, an enterprise security lead, summed up beautifully why this paradigm shift is such a big deal. We're used to treating security as a gate that inherently creates capacity limits, massive backlogs, and eventually engineers just find workarounds. But MDASH transforms this into security as an environment. It's a continuous, autonomous inspection. It runs on every single commit, endlessly reading code, and it never, ever needs a coffee break.
In this new environment, it learns incredibly fast. Just 3 weeks after launch, MDASH's CyberGym benchmark score jumped from about 88% to over 96%. But here is the fascinating takeaway. That massive leap didn't happen because they upgraded the underlying AI models. Nope, it happened because the harness itself improved. The debate logic got smarter. The structural pipeline itself is what's actually learning here.
Section 6. The AI scaffolding debate. What comes next for AI security? Now, not everyone in the tech community agrees on this approach. So, the crucial point is understanding this philosophical divide. Researchers over at Expo argue that these rigid harnesses will actually eventually constrain highly capable future frontier models. They think systems like MDASH are essentially just scaffolding built for older models, and that native AI will soon completely outgrow them. Scaffolding outliving its usefulness, basically. Microsoft, on the other hand, strongly counters that this debate-and-proof architecture is absolutely essential quality control. Their stance is that raw model capability doesn't just automatically grant adversarial discipline. Without a system deliberately challenging itself, even a totally brilliant AI is just going to flood you with false positives.
Today, the networking stack that literally hundreds of millions of us depend on is safer, simply because MDASH caught a ghost that human minds couldn't hold. But as we look ahead, we're left with a really critical question. Will rigid AI harnesses eventually constrain the limitless capabilities of future models, or will they forever remain the essential quality control we desperately need? It is a truly fascinating debate, and we'll definitely be watching it unfold. Thanks for joining me on this explainer, and keep questioning the code around you.